Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a systems and mechanical engineer, and lately I've been doing some electrical engineering as well, and as a theoretical physicist. As usual with my weekly screencast, I'll be talking about the reciprocal system versus conventional theory. We have two topics today. First is planets around red dwarf stars, and the second is a new supernova discovered back in 2014, which we'll discuss in a moment. So let's look at this first topic, planets around red dwarf stars, and this is from Science Daily. As usual, I like to go to Science Daily. It's a good source for research news. So this is what they say. Virtually all red dwarf stars have at least one planet in orbit around them. And the summary, 3 new planets classified as habitable zone super-Earths are amongst 8 new planets discovered orbiting nearby red dwarf stars. A new study identifies that virtually all red dwarfs, which make up at least 3/4 of the stars in the universe, have planets around them. The research also suggests that habitable zone super-Earth planets, where liquid water could exist and making them possible candidates to support life, orbit around at least 1/4 of the red dwarfs in the Sun's own neighborhood. Okay, this discovery is actually perfectly consistent with the reciprocal system. So let's just go back here. And I say in the WordPress blog, and I'm going to annotate it as I usually do for YouTube. In conventional theory, stars with the mass of our Sun eventually become red giants, which eventually become white dwarfs, which eventually become black dwarfs, which is the end stage. Again, that's conventional theory. From main sequence to red giants to white dwarfs to black dwarfs. That's certainly not the reciprocal system. In the reciprocal system, which was developed by Dewey B. Larson, and what I've done is to make it fully computational. Stars like our Sun slowly move up the main sequence, eventually explode in a supernova, which creates a red giant white dwarf pair, or a red giant and a planetary system. The red giant then decreases in size and increases in mass to become a red dwarf. This red dwarf then slowly moves up the main sequence and the cycle repeats. Therefore, it is not a surprise to us that there are so many red dwarf planetary systems. There should be. It means that those stars have gone through one cycle already. So half of all stars in our galaxy are members of binary or multiple star systems. So if you look at most of the stars that you see in the sky at night, most of them are actually binary or multiple stars. The other half are divided between individual stars and solar systems like ours. Okay, so here we don't disagree with this report from Science Daily, but we explain it very well. All right, let's move on to the second topic, this new supernova. And as usual, we'll go to Science Daily. And it says here in the summary, the closest and brightest supernova in decades, SN 2014J. By the way, that means supernova. 2014 is the year, and J means, well, you go A, B, C, D, E, F, G, H, I, J. Brightens faster than expected for type 1A supernovae. The exploding star is used to measure cosmic distances according to astronomers. Another recent supernova also brightened faster than expected, suggesting that there's an unsuspected new physics going on inside these exploding stars. The finding may also help physicists improve their use of these supernovae to measure cosmic distance. And, well, let's look at this picture here. Now look how bright this supernova is in this cigar galaxy, so-called cigar galaxy Messier 82. This shows a color composite of SN 2014J, 11.4 million light years away, made from KAIT images obtained through several different filters. Supernova is marked with an arrow. Wow, you can just see how bright that is relative to the rest of the galaxy. Other round objects are relatively nearby stars in our own Milky Way galaxy. And the credit here is from W. Zhang and Alex Filipenko. Alex Filipenko is a well-known astronomer, textbook writer, etc. So let's just see what they're saying here. Just scroll down. Combining this observation with another chance observation by a Japanese amateur astronomer, Filipenko's team was able to calculate that SN 2014J had unusual characteristics. It brightened faster than expected for a Type 1a supernova, and even more intriguing, exhibited the same unexpected rapid brightening as another supernova that KAIT discovered in an image last year, SN 2013DY. Now he's saying here, now, 2 of the 3 most recent and best observed Type 1a supernovae are weird, giving us new clues to how stars explode, said Filipenko, referring to a third, though apparently, quote, normal, Type 1a supernova, SN 2011 FE, discovered 3 years ago. Quote, this may be teaching us something general about Type 1a supernovae that theorists need to understand. Maybe what we think of as normal behavior of these supernovae is actually unusual, and the weird behavior is the new normal. Well, I don't know about that. Let's see if there's anything else here we want to go over. Well, it says here, this is the conventional nonsense. It says, a Type 1a supernova is thought to be the explosion of a white dwarf, an old and very dense star that has shrunk from the size of the Sun to the size of the Earth. When a white dwarf has a stellar companion, it can sometimes gain matter from it until the white dwarf becomes unstable, completely obliterating itself through a gigantic nuclear explosion. Well, that's just pathetic nonsense. All right, let's just go back. And I say here, the problem is that conventional theory says that supernova Type 1a are due to the transfer of matter from one star of a binary system to its white dwarf companion. This is dead wrong. White dwarfs do explode, but that's due to another cause, and the result is a nova, not a supernova. Actual Type 1a supernovae are due to reaching a temperature or mass limit in the star, in which a portion of the iron or iron-nickel core is converted into energy. So please read Dewey B. Larson's astrophysical masterpiece, The Universe of Motion, and read my software ebook, Existence and Interactions, a Computational Treatise on the Reciprocal System, the True Theory of Everything. So let's just review this a little bit. If you want to know the simplest possible treatment of the reciprocal system theory, obtain my book, The Unmysterious Universe. The most comprehensive work is my software ebook, just mentioned, Existence and Interactions, a Computational Treatise of the Reciprocal System, the True Theory of Everything. It's thousands of equations, 711 pages. You'll be spending months studying it. And you'll see how everything fits together in the physical universe. It even has some metaphysics in there and some econophysics as well. And then if you want to apply the reciprocal system to your scientific or engineering practice, I have 2 database modules. The first is for the microcosmos. It's called the Reciprocal System Microcosmos Database, and the second is the Reciprocal System Macrocosmos Database. The Microcosmos database is for photons, subatoms, atoms, and compounds, and the Macrocosmos database is for all the astronomical phenomena, moons, planets, nebulae, galaxies, galaxy clusters, the universe as a whole, of course, stars, voids, everything. Everything's in that database. So study the reciprocal system and prove it for yourself. Please subscribe to my channel for the latest news. And if you like my posts, please hit the like button, please. Thanks again. Thanks for your attention.